So let's talk a little bit about variadic functions. Before we were working with functions where we had a positional argument, so we had something like kind, and then arbitrary positional value of parameters, and then keyword parameters, right? The thing is, this function, the way it is right now, it requires to have at least one positional argument. When we just have the keywords as args and keyw or keyword args here, it means that this function is characterized as a variadic function. So we can take any number of arguments, positional and keywords, which is pretty cool, right? So let's run this here and do the exercise of running all the cells at your place and see if you can understand the output of this. So, for example, in this case right here, since we are not providing any keywords, so when we printed out the keywords and that the list of keywords is being, or the dictionary of the keywords, it's empty here in this case. Whereas in the second example, as we have here, we see that we have two positional arguments, like 1 and the keyword "and" here, which is just one. We have one keyword, which is pretty cool, right? Now, if we try to run, and we saw this example before, if we try to call a keyword argument before positional argument, we're going to have an error. Why? Because all positional arguments, arbitrary or not, they must come before our keyword, okay? And since all of them, they are arbitrary, it means that if we don't pass anything, it's going to work out for us, right? Let's see some more clever examples. I think this one here, it's pretty interesting. So let's try to evaluate before we run this. What we're saying is we're going to have a positional argument, and then we're going to unpack this entire list here as positional arguments. So it's not like the list is being placed as one single positional argument, but all the elements, we're going to unpack them, and we saw this already, how this function here works, right? And then after that, we start with our keyword arguments, and as we can see here, the first keyword argument, it's k equals 1, and then what we do, we unpack our dictionary, our keywords into our list of keyword arguments. So let's take a look and see how that goes. So as we can see here, 8, and then it's followed by the list being unzipped or being unpacked, right? And then we have all the keyword arguments following the order in which they were placed. I guess you can figure out how this guy here works. It should be the same thing. Here, instead of just, let's run this here so we can do all about it. Let's see how this is. The same way we can unpack a list, as we can see 3, 4, and 5, as in 3, 4, and 5 right here. This is also part of our positional arguments, and then we are unpacking a tuple, as in 4 and 1. So it's the entire list here, it's being considered in one single tuple of positional arguments, right? And by the time we start doing their keyword arguments, they follow the same structure as we had it before. I guess the last example is more interesting for us, that we don't necessarily, the same way we use lists here and tuples, in this case we are unpacking them, we can pass entire structures. And this entire structure is being considered as a positional argument. So as you can see here, let's run that. The first example right here, what we're seeing is this entire dictionary structure is being considered as one positional argument, whereas the pair here, the other pair or the other dictionary, we are unpacking. So we have the value, since this is a dictionary, what we're actually unpacking here is the key for these guys. So A and B here, and then the last one here follows the same structure as we had it. Okay, so thank you and happy coding.